Hello, and welcome to the Autodesk Ecotect tutorial. Today we'll be using the model used in the previous tutorial. To begin with, we're going to click on the Revit icon, click on Export, and click on GBXML. Now, for the room volumes not computed window, we're going to click on OK, and click Yes, sorry. Now, as you can see here, we've got three rooms: the office, meeting room, and the lobby. So what we're going to do is we're going to set the building type, make sure this is office. In the location, we're going to change that. We don't want London, we're going to set that to Leeds. So we're going to use the Internet Mapping Service. So what we're going to do is move the icon, zoom out a bit, and take the icon up to Leeds. Now for your model, if you're following this tutorial, you can set any location, it's not really a problem. Just zoom in a little bit. We will put the building near the university. I think, yep, near the university. So we'll drag it up. We'll put it about there. Click OK. Make sure ground plane is OL ground level, project phase new construction, silver space tolerance 304.8. For the export complexity, make sure it's simple with shading surfaces. Now if we click on the details tab, we can open up the ground level folder and we can see each of the rooms. Now if you click the isolate element button, we can isolate each room and we can see, yep, these are the three rooms. Now if we click on the analytical surfaces button, you can see immediately every element in the structure appears. Now if we open up all three rooms, we click the isolate, we can see we've isolated room 2, the roof, exterior walls, interior walls, and floor. Now just go through everything, make sure everything's okay. Sometimes you might have an air gap in the room. In that case, it might slightly affect your results in Ecotec. It won't be 100% accurate. So you need to go back into the model and make sure you remove the air gap. Click Save Settings. Give it a second to load. Okay, now it's loaded. We are going to go and click on the Revit icon again. And we're going to export GBXML. Click Next. And we're going to save this. Now I've already got one saved. It doesn't really matter where you save it. So as you can see, yep, I've got one here already saved. So I'm not going to save it, however you need to save it. And click Save. Then when you're done, you need to run Ecotect. So we'll type in Ecotect Analysis. Just wait for this to load. This is a student trial version, so we'll just click Try. Right, so here's Ecotect Analysis. We've got it up and running. So what we need to do, click is File, Import Model Analysis Data, and we need to find the XML file. Click on Desktop, Tutorial.xml. There it is. Click on it and click Open. Now, as you can see, if you remember from the Revit tutorial, we named each element with, so each window we called it, we put the word window in. With the doors, we put the word door in. So as you can see, Ecotect has identified those elements as windows and doors. And click Done. And here's the model. Now the model I'm using here is slightly different from the one created in the tutorial. It's got two front windows and pitched roofs. This doesn't make any difference whatsoever in the procedures which I will be going through today. So here's the model. So the first thing we need to do is find out, where the sun is coming from. So we're going to open up default GL settings, technical shadow settings, display shadows. Give it a second. There's the shadows. So now what we need to do is, where's the sun actually coming from? Where is it in Leeds? So to do that, we're going to click on the globe icon, load weather file. We're going to scroll down now. There isn't a Leeds here, the closest is York, so we'll select York and click open. Yes, update the global position. And the shadow's changed. Perfect. Now if we check daily sun path, you can see the daily sun path and the annual sun path. You can click only one or have them both, whatever, it's up to you. We'll actually have just the daily. Now what we're going to do is, we're going to work out how much solar energy is reaching the building. And as you can see, we can use this tool at the top, the time tool, just to edit the position of the sun. However, this does not affect any of the analysis, what you're going to do, or any of the calculations. This is just, it just allows you to have a visual interpretation of where exactly the sun will be at any time in the day during the year. So let's calculate how much solar energy is going to be absorbed by the surfaces of the building. So we'll click calculate, solar access analysis, incident solar radiation, and click next. Now if we just set these numbers here, make sure you set all these numbers as they are displayed here. Give you a second to change them. Then we'll click next. The cumulative values, click next. Objects in model, click next. Use existing shading tables, yep, click next. And then you click OK. However, it takes a while for this calculation to complete. So I've got one already finished, so I'll click cancel. And your model should look like this. This is my completed calculation, and as you can see, the front of the building is a lot warmer than let's have a look, than the back. Yeah, as you can use the key on the right hand side to see the difference in watt hours per meter squared being absorbed. So what we can do sometimes is change the orientation of the building. Now this is very important, so we can go into the project tab and into the site specifics. Yep, over here. We can change the north offset. If you look at the black line, the thick black line, there, it changed. It rotated 90 degrees clockwise. Now if we go back into the Visualize tab, you can see that the building has rotated clockwise 90 degrees. Now we can, you can again calculate the solar access analysis and see how it's changed. However, it's easier if we use the best orientation tool. So to do that, we'll run the weather tool. Just makes life a little easier. We should get the try. Yep, here, because it's a student version, we'll just click try. Give it a second to load. And there it is, the weather tool. So now you should see that the location data should match the climate selected earlier. Now if we click on solar position and click on best orientation, Ecotec will automatically determine the best orientation. We'll just select the 3 hottest and 3 coldest months and click OK. It should already be selected. Give it a second to load up. There. Now Ecotec has determined that the best orientation is 170 degrees from north or 10 degrees from south. So now we can use that and change the orientation of our building to give us the best results. So we'll click close. Now let's just have a look exactly where that is. Should see that 170 degrees is about here. So we go into the project tab, site specifics, change that to 10. Now in the visualize tab, you should see that the building has perfectly rotated 10 degrees from south. So now our building is south facing, not perfectly south facing, but 10 degrees from south, which is about here. Now this has provided the best orientation for our building. Now the next thing we need to do is to tell Ecotec what's in our building. So to do so, we're going to go into the Zone Management tab. We're going to select rooms 1 and 3 because they are identical. So select 1 and 3, right click on it, and we'll select Zone Properties. Now from this window we can change the lighting level, the number of people, the type of system used to heat and cool the building. So what we're going to do is we're going to set the lighting level. It's an office desk. Number of people, typical office. Recalculate, yes. I'll select typical office again and the number should change. Okay, 6, perfect. Now we'll select the sensible gain, we'll leave it at 20. And now what we can do is you can click on this cog icon to change the schedule for the building. Now what we're first going to do is select all of the weekends. Like that. Click on standard weekend and click on assign. Now we need to select the public holidays. We'll have those 2 weeks there. 1 week here. You know, the exact public holiday dates is not really a problem. You can just go into Google and find out where when your public holiday days are and assign them. But this is just process. Now click on any other day. Click on standard weekday. Now we can change these values to say when the building will be occupied. So 7 o'clock, let's say we've got 20% of people in. 8 o'clock, 60%, and by 9 o'clock everyone's in, so we're at 100%. Now at 10 o'clock 100%, 11 100%, 12 o'clock 80%, some people have gone to lunch. 1 o'clock, let's say 50%, 2 o'clock we've got 80% of people again, 3 o'clock we've got 100, 4 o'clock 100, 5 o'clock 40, I think most people have gone home, and then 6 o'clock 10. And that's the schedule. Now we need to name the schedule. In this case, let's just call it My Schedule. And click on Apply. Add it to the schedule list, yes. And there we go. Now we can select it from My Schedule, My Schedule, and My Schedule. Now we can go into the Thermal Properties tab. We can change the type of system to mixed mode. Upper band to 22 degrees. Hours of operation, let's say from 7 in the morning till 6 in the evening, 18. And weekdays we'll have it off. And that's that. We've set rooms 1 and 3. Now what we need to do is to set room 2. So we click on room 2 up in the upper left hand corner. Now we need to change both the thermal and general settings. So we'll change the lighting level to 200. Office crowded, yes. Office crowded. We'll have the people walking because it's the room 2 is the lobby. So sensible gain at 5. You know, people are chatting. Set all the schedules to My Schedule. The thermal properties to mixed mode system. 22 degrees, upper band, off at 6, on at 7. And the weekends will have it off completely, 0 to 0. Now we'll just check room 1, 2 and 3 are the same, and then general settings 1 and 3 should be the same with 2 slightly different. Perfect. Now we'll click on OK. Now what we can do is use those entered inputs to calculate how much energy we require to maintain 18 to 22 degrees. So click calculate thermal analysis, click on space loads, click next. Now you should have these 3 zones. If so, you click on OK to calculate how much energy is required to maintain the thermostat at those temperatures. However, I've got one calculated here already. Go on analysis, and this is what you should get. You see that in January, February, March, April, and May, we need quite a bit of heating. September, October, November, December is the same, whereas June, July, and August, warmer months, so we're going to be needing the cooling systems. Now, if we look here on the bottom, this displays our results numerically rather than graphically. We can see that we require 38 million watt hours throughout the year to maintain the temperatures 18 to 22 degrees. So what we can do is we can now look at, where is this heat being gained, where is it being lost. So to do so, we can click on thermal calculation here and do the passive gains breakdown. Click on that, click on calculate. Give it a second and you can see it's calculating where the heat is being lost, how it's being lost, and how it's being gained. Right, so now immediately you can see this red, which is conduction, green solar. The conduction is contributing to most of the losses and solar is most of the gains. So if we look, actually the fabric, which is the conduction, it amounts to 89.5% of the losses, which is a lot. The solar, 48.3% of the gains, which is reasonable. So what we need to do is we need to change the model. Because through BIM, which this system is, it needs to be dynamic, it needs to change. So what we can do is we can change the material properties to see how that changes, how much heat energy is required. So to do that, we're going to click visualize and we're going to change materials. So we'll click on select by element type, click on the windows. Now if we click on the selection information, you can see that the primary material, if we click on properties, you can see is single glazed timber frame, single pane of glass with timber frame. Now here you can see the values which Ecotec would use, the U value, the solar heat gain coefficient, etc. So you can use these properties to have a look at the properties of the material. However, we're just going to change the primary material from single glazed. We can change it. We can select material and we can select double glazed timber frame and click OK. Now we can also change the alternative material. Click OK. Now we can also change other materials, so we'll change the walls. Now the walls are brick timber framed, so we'll change that. We'll select material and we'll click double brick cavity render. So that's brick, cavity, brick. Provides much better insulation. Change the alternative material. Now we can rerun the analysis to see what effect that has on the results. So we click on the hourly loads discomfort, monthly loads discomfort, and scroll down. See here, before we had 38 million before changing the materials. Now if we click on calculate, give it a second to load. If you just watch the graph, it should change there. Immediately you can see all the values reduced, and there, 30 million. We've reduced the watt hours required each year to maintain the thermostat between 18 and 22 degrees by 6 million watt hours. So immediately we can see the Ecotec is allowing us to change the model. It's giving us options analysis. Now we can explore that further. We can change the wall from brick to concrete. So we'll change the primary material. We'll change it to concrete block render, I think. Yep, concrete block render. Now what this does, it gives the client options. He can visually see the difference between brick and concrete. And now with this, we click calculate, he'll be able to see the difference in energy consumption for the building. So here earlier we had 30 million, now we've got 36 million. So as you can see, we've increased the watt hours required by 6 million just by changing the wall materials from brick to concrete. So as you can see, brick is much more efficient at containing the heat in the building. So we'll change the primary material back. Click OK. Select material, double brick cavity render, click OK. Now if we click calculate again, it should go back down to the 30 million which we had after our first analysis change. Give it a second to load. And there we go. There's the 30 million which we just had before. Now, as you can see in our 3D editor, we've got two large windows at the front. So let's remove them and see what effect that has. So now what this is all about is change. Let's see what effect doing this has, doing that has. So if you remove those windows, let's see the effect on the heating and cooling requirements. So click on analysis, click calculate, and now it needs to recalculate. So this will take a while, so I'll skip this. I will just pause the video and come back when it's calculated. Right, the calculation is complete, and as you can see from these results here, 26 million. We dropped from 30 to 26. We saved 4 million by removing the large glass windows at the front of the building. However, that might not be reasonable because aesthetically the large windows look nicer. You know, here we've just got, you know, a large solid wall, no feature. However, it has provided us with the option of being able to analyze and see the difference between window and no window. Now let's change more materials and see what we can get. We'll click on select by element type. We'll change the roof material. We'll change it from metal deck. We'll change it to concrete. I know it's rather heavy, however it's got much better thermal properties than a metal deck. So we'll click concrete roof, click OK. Now we will change the ceiling materials. Primary material, select material, ceiling. Now there's no concrete, so we'll click on roof, then there's the concrete and click OK. Now repeat the process for the alternative material. Roof, asphalt, OK. Now we'll select by element type. We'll change the walls, make sure it's on double brick, yep, okay. Select by element type. We can change the windows, double glazed, actually, yeah, we'll change the windows. We'll change them from double glazed, we'll select material, double glazed timber frame to double glazed aluminium frame. Click OK. Click aluminium frame and click OK. Now we'll click on select by element, select by element type. We can change the doors. So we've got solid core pine here. You know, they don't look very nice, so we'll change that to a glass sliding door. Alternative material, select material, glass sliding door. Okay. We'll also select the floors, change that from just a plain simple concrete slab to a concrete slab with timber finishing. Click OK. Change the alternative material, timber, click OK. Right, now if you click on the analysis tab, we can rerun the analysis and see what effect that has. Now earlier we had 26 million. Now with all those changes, once this calculation's finished, we'll see the difference, and we've got, wow, we've saved more than 11 million. That's 15 million there, which is, you know, that's 50% from the original 36 million. And this is what BIM allows us to do. It gives us these options. Thank you for watching this tutorial. And before we finish, let's have a look at the passive gains breakdown. Click on calculate, and let's actually see if anything changed here, because we use more insulative materials. So let's quickly have a look. Brilliant. We can see that the losses has decreased significantly, you know, from 89 to 75, and the gains has been distributed a lot nicer, which is brilliant. So yeah, thank you for watching this tutorial. I hope it's helped, and please tune in to my next tutorial. Thank you for watching.